Looking at this question, we should straight away pretty quickly see that we've got an implicit equation up here. We've got the equation of a graph, but it contains a mixture of x's and y's. It's not rearranged nicely to y equals. That's precisely an implicit equation. And so the chances are this question is going to involve differentiation. Let's actually read it. So P lies on the curve C. The tangent to the curve at point P is parallel to the x-axis. And again, it's talking about a tangent. Tangents to a curve, we need to find the gradient function. And let's be more specific and think about what parallel to the x-axis means. Well, on any graph, obviously x is horizontal and y is vertical. So parallel to the x-axis just means some kind of horizontal line. So it's talking about where the tangent to this curve is horizontal. And that will happen when dy dx equals 0. Now, I'm not going to draw the actual curve there, but you might have a graph like this. And at this point, I've just missed, but in theory, at that point, the tangent is horizontal there because dy dx equals 0 there. Okay, so let's go back to the implicit function. We'll just copy it down for a second, and then we'll look at differentiating it. So we've got sine x plus cos y equals a half. And we're going to differentiate both sides with respect to x. Some shorthand there, differentiate with respect to x. So go term by term. Sine x differentiates to cosine x. Cosine y, cosine differentiates to minus sine, so we get minus sine y. And if you remember in implicit differentiation, because of the chain rule, this gets multiplied by dy dx. And then on the right hand side, a half differentiates to 0. It's a very common mistake to forget to differentiate both sides of the equation. Okay, so we've differentiated and we can rearrange that to get dy dx. The subject dy dx equals cosine x divided by sine y. Okay, so we decided already that if the tangent is parallel to the x-axis, then that means parallel to the x-axis, that means that dy dx equals 0. So we're going to make some progress from there. So we've got our function now for dy dx. That's cosine x over sine y. That must equal 0. Multiply both sides by sine y, and therefore cosine x is 0. Now obviously cosine is a many-to-one function. There's lots of angles whose cosine is 0. So let's just check back up the question. We've got this restricted domain for x. So we only want x values in that interval. So if cosine x is 0, then that means that x is pi over 2. That's the principal value. Minus pi over 2. That's the partners, the principal value. And there won't be any other x values in the domain that we're given. So we've got 2 to follow up on. Because if you notice the language of the question, I'll highlight a bit more. Find the coordinates of all possible points P. There may be more than one point that we're finding. And we've already got 2 candidates for x coordinates. So now we need to think about y coordinates. So we need to come back to the equation of the curve C, substitute our x values, and see how that works out for y. So we can do a bit of work over on the side so that we don't have to scroll. Let's look at the first case, which is when x equals pi over 2. And we substitute that into the equation of the curve. Sine pi over 2 plus cosine y equals a half. Sine of pi over 2 is 1. So 1 plus cosine y is a half. Cosine y is negative a half. And there are 2 angles that make that true. We've got 2 pi over 3 is the principal value. Negative 2 pi over 3 is its partner. And again, if we come back to the question, we've got this restricted domain for y values as well. We're only looking between minus pi and pi. So those are the only values that we have. There was a second situation that we had to check. Another possible x, which is x equals negative pi over 2. Let's see what happens then. We've got sine of negative pi over 2 plus cosine y equals a half. Sine of negative pi over 2 is negative 1. And therefore cosine y must equal 3 over 2. Well, that's not possible. That has no solutions. And if you really had to justify that, you'd say because cosine y is between -1 and +1. So therefore, we only have two answers to this equation. Let's highlight them before we write them down. But they both happened when x was pi/2. One gave us a y value of 2π/3, and one gave us a y value of -2π/3. So our final summary answer, therefore, P is either π/2, 2π/3, or π/2, -2π/3. And we're done.